Okay, let's enter the content here. CFD easily explained. These are some basics that are really fundamental for you to get everything we will be touching upon in this webinar. We have to start with the basics. You should have a basic understanding of what CFD is. CFD, Computational Fluid Dynamics, is actually a physics tool by heart. So the core is really physics equations. We will not put them on the slide here. They are quite sophisticated, but luckily there's very good software to solve these equations. It's not a trial and error process. What do we mean with that is it's a physics model that is really by nature quite accurate if you apply it properly. And then you can structurally apply it to actually get to your goal. One example on this slide is an existing system. At the left, this is a wastewater treatment plant. It can be any system, drinking water, storage basin, whatever. In this case, it's a reactor. It can be an existing or a non-existing system because the reactor doesn't have to exist, right? The first step you do is build a 3D geometry. So you construct a 3D geometry that is quite simple, actually. It doesn't need a lot of input to make. And then you include the relevant elements. What are the relevant elements? Inputs, inlets, outlets, aerations, aerator locations, mixers, if there are any, etc. These are the critical elements. Then we mesh it. So we divide this reactor in little cells. For example, if your reactor is, let's say, 1,000 cubic meters, and you have 1,000 cells, the average volume of one mesh cell is 1 cubic meter. That's how it conceptually works. And then finally, you get the nice colorful drawings most of you are probably familiar with. It's the output. The output can mean different things. It can be the most conventional output, a dead zone, velocity vectors, but it can be 3D concentrations of oxygen, ammonia. It can be particles. It can be sludge. It can be the gas holdup. It can be viscosity. It can be lots of things, actually. But we will not go into detail in this webinar because this will lead us too far. We have a lot of webinars and other content on our website if you're interested in. But this is the interesting thing when you look at CFD. When you have this output, you see things that are not optimal. In this case, you can see this red zone. Actually, this red zone indicates local high dissolved oxygen. It's all concentrated at one spot. You don't want it there. So you can do what-if scenarios while not having to actually do any modifications or tests with your real system. And then you can do, again, some simulations and visualize what's better. And finally, you find the optimal solutions or the final optimal designs that can be brought in practice. This is conceptually the core of the value CFD brings, testing flexibility and being able to really understand how you can properly design and operate your system.